My name is Sumit. I'm from Thakur College, second year student. Today I'm going to solve a question, coin quest. It is a medium level of question. Let's solve the question. Here is the problem statement. The problem statement has two characters, Alice and Bobs, and they are exploring a mysterious ancient temple. Inside they find a treasure chest blocked by a mechanism that requires a specific amount of money to open the chest, accepts coin of 1, 2, 5 and 10, and the challenge is to find the minimum number of coin needed to unlock the chest for a given amount n. This is the problem statement. The goal is to determine the minimum number of coins to require to make given amount n by the value of 1, 2, 5 and 10. We can only use this for so let's solve the question, and the constants are 1 to 1000. Yeah, let's solve this. I'm going to use Python language to solve this question. Here I'm defining a function with name coin change and get two inputs and the coins. Coins are 1, 2, 5 and 10, and n is the value of number. We initialize the array with maximum value. The float infinity is the used in Python for initializing the maximum values, and set dp of index of 0 is equal to 0 because no coins are needed to make the amount 0, and we use two for loops I and j. The outer loop for I, this loop iterates over every possible amount from 1 to n plus 1, and here is the inner loop j. The loop goes through the all values of available coin, which is 1, 2, 5 and 10. For each coin, we use if condition to check coin of j, which is coins are 1, 2, 5 and 10 should be less than and equal to the I. If it is valid, then we move to the next statement, which is the important line for this code and problem, which is dp of I is equal to minimum. Minimum function is in Python give the smallest value, and dp of I, which is array of outer loop, and dp of I array holds the minimum number of coin needed to make the amount I. Initially, all the values of array dp is infinity by using float infinity, and this condition dp of I minus coins of j represent minimum number of coin needed to make amount I. This refers to the previous computed value of array, and we added plus 1 to the current coins that you are using to reach the amount of I. This is used for the compute the minimum number of coin needed to make amount I, and all the dp of I always store the minimum coin required to make I with the help of minimum function, and we return the dp of n at index of n, which store the minimum number to reach that to reach that point. And here is the we use here we use t for multiple input values, and which is our input value for integer, and coins, as we say 1 to 5 and 10, we can only use this for to get the minimum possible value, minimum smallest possible value required to make I. This code has time complexity of O of n square for each test case. Let's go to this question and run this. Yeah, we passed the test case. Let's submit it. Congrats, we pass all the test cases. Here I use another logic to solve this question. Let me show you. Here is I use another logic to solve this question by initializing the array 10, 5, 2 and 1 and the count variable with the value 0. In this we divide the number n with the coin which is 10, and we get the quotient value for this number, and we increment the count variable with remaining quotient value, and the number remainder which is left, we again divide it by the coin value. This time it is 5, and we continuously doing this in loop for getting the smallest number, and it is more efficient code than the previous one. It has time complexity of constant time of 1 and the space complexity big of 1. Here we use function for input values. Let's solve a question with this logic. Let's take an example of 58, and our code says we have to divide number with the coin value which is 10, and if we divide it by 10, then we get the quotient value is 5, and the value 5 we count it and increment count value by 5. Okay, then remainder of 58 by 10 which is 8. Okay, then we are in a for loop, so we again divide it by 5. So we again divide it by 5, so we get the value quotient value 1, so we increment it by 1, so it gets 6, and the remainder is now 3. So we are in a loop, so the next value is 2. We again divide it by the remaining value by with 2, so we get 1 plus 1 again, so the quotient plus, and the remainder is 1. So in a loop we have last 1, so we divide it by 1, so count is incremented, and so it will be 8, and the remainder is 0. For this question we have solved with example 58. Thank you for watching this video.